Okay, I will not just assume that you already know what the binomial theorem is. I'll just start from the beginning. So, okay, you already know Pascal triangle, and Pascal triangle helps you get coefficients of your binomial expansion. When you're asked to expand the binomial raised to a certain power, your Pascal triangle will give you your coefficients. Then you that will put your powers by yourself. That is putting A in ascending order, putting A in descending order, putting B in ascending order, that kind of thing. So you can get your coefficients using Pascal triangle, and another way to get the coefficients is using binomial theorem. The same way Pascal triangle works, the same thing that Pascal triangle do, that's the same thing that binomial theorem do. They only get your coefficients. You're the one that will put in your powers by yourself. Not putting your powers, they only help you get your coefficients. So your Pascal triangle is very helpful. Actually, me, I use Pascal triangle a lot, but when you see an expansion, which of course occur rarely, where you have high powers like raised to the power of 20, to construct your Pascal triangle up to that 20th step or 21st step is going to be very difficult for you, and no space to do that kind of thing. So the best thing to do now is use your binomial theorem for such large powers. So let's take something that is common. I want to explain some terms now. So let's take a common expansion that you already know. That is a plus b squared. A plus b squared. If you expand it, either use Pascal triangle or use normal algebraic expansion, you get a squared plus 2ab plus b squared. When you expand it, you get a squared plus 2ab plus b squared. So you can see that there are three terms here. I explained something like this before. There are three terms in this expansion. The number 3 is 1 greater than the degree of your expansion. The degree is raised to the power of 2. There are three terms here. It's greater than 2 by 1. So this first term, so I'm going to give them a value of their position. They have position. These three terms, we'll give them their position now. This a squared is the first term. We'll give it the position value of 0. Okay, let's represent this position by r. The position of a squared now is 0. That is the first term. And the second term, that is 2ab. We will give it the position, that is r, the position of this 2ab now, we'll give it 1, that is r is equal to 1 for this second term, that's 2ab. Then the last term, that's the third term, that's b squared, we'll give it the position value of 2, that's r is equal to 2. So I started from 0 because I want to get the position of the last term, that's b squared, to be equal to the power of your expansion. So that's why I see that that b squared, the position value is 2, r is equal to 2, 2 is the power of expansion. So it's good I started from 0 there. So we're using r as the symbol for the position of what we have. Now, the binomial theorem states that when a binomial is expanded to a degree of n, let's say n could be any number now, so such as something like a plus b raised to the power of n. I'm going to use a and b. I don't know in your lectures the letters that they are used. I'm going to use a, b, n, and r. Those are the letters I've used. I don't like the letters they use in lectures. So the binomial theorem states that when a binomial is expanded to a degree of n, such as a plus b raised to the power of n, and the coefficient of a term, after you expand, the coefficient of any of the terms there depends on the term position r by the formula. The coefficient of that term depends on the position, that r that we're putting here. I say r will start from r equal to 0, r equal to 1, r equal to 2. The coefficient that term will have is depending on that r by the formula n combination r. So n combination r is actually the coefficient of each term in a binomial expansion. N combination r is the coefficient of the term in a binomial expansion. So the coefficient of the first term, remember our first term, the r value is 0. Our second term, the r value is 1. Our third term, the r value is 2, and so on. So if you want to get the coefficient of the first term, that's n combination 0. Want to get the coefficient of the first term, n combination 0. Remember, the formula is n combination r, and the first term r is 0. That's why I'm having n combination 0. Okay, you can use your calculator. You will get that n combination 0 is equal to 1. I also have rules for combination somewhere. Rules for combination, I'll send to you later. Rules for combination. One of the rules is that n combination 0 is 1. N combination 0 is 1. Now, if you want to get the combination for the coefficient for the second term, It's still using this formula n combination r. The second term has the value of r as 1. So instead of n combination r, you have n combination 1. See from one of those rules, or you can still use a calculator. N combination 1, you get n. That is, n could be any number. It could be 6 combination 1. Use a calculator, you see that you still get 6. 3 combination 1, you still get 3. So n could be any number that you want to use this as. So n combination 1 is n. N combination 1 is n. And this means that for that first term, that r is equal to 0, you will always get the coefficient as 1. Because when we use the formula, we got 1. No matter how big the expansion is, the first term, the coefficient is always 1. The second term, that's when r is equal to 1. The second term, like we just got, is always equal to n. When we got this n combination 1, we said it's equal to n. So our second term, the coefficient is always n. That's n is the power of your expansion. We say it's the power of 6. The second term, the coefficient is always that power. It was also seen in the Pascal triangle. Like the second term in each row is the power of that row. You remember in your Pascal triangle. So the second term of your expansion is always that power. Now, if you skip to the last part, to the ending of your expansion, the last from back, you see that the last term of your expansion, the value of r is equal to the power. Like we said, for this a plus b is power of 2. The last term, that b squared, the value of r was 2, and 2 was the power of your expansion. So the value of r at your last term is always equal to the power of expansion. So the value of r at your last term is n. So r is equal to n for the last term. That's the value of r for the last term. R is equal to n for the last term. So now if you're using your formula n combination r, that is to get the coefficient of that last term, n combination r, to get the coefficient of that last term, you will see that it will actually be n combination n, because you say r is equal to n for that last term. So n combination n means like, so it has 6 combination 6, 2 combination 2, 4 combination 4. Try all this with your calculator, you see that you get 1. It's always going to give us 1. It's also bound of the rules of combination I wrote down somewhere, I'll send to you later. N combination n is equal to 1. So you can see that the coefficient of that last term is always 1. And it coincides with your binomial, with your Pascal triangle rather. One term, the first and the last term are always 1, 1. Like we just got our first term coefficient is always 1. Now we're getting it now. Our last term combination is also 1. Now let's check the second to the last term. What is the coefficient? Second to the last term, that's the term before the last term. What will be the r value? That will be r equals to n minus 1. R equals to n minus 1. If the last term r value is n, then the term before it will be n minus 1. Term before it will be n minus 1. So r is equal to n minus 1 for that second to the last term. So using your formula, that is n combination r. Instead of having n combination r, now you have n combination n minus 1, because you just said that r will be n minus 1 for the second to the last term. Now, based on one of the rules of combination, or one combination that I have, you also get that n combination n minus 1 will give you n. The answer will always be n. Like for instance, if you try 6 now, try 6 combination 5. That I'm getting 5 because I'm doing 6 minus 1. 6 minus 1 is 5. 6 combination 5, you get 6. If you try 10 combination 9, you get 10. Try 20 combination 19, you get 20. 105 combination 104, you get 105. So that's what that n combination n minus 1 means. You always get n. That's the degree of your power. So that means n is your degree, right? Remember, n is your degree. That means the second to the last term, the coefficient is always the degree of your expansion. And it also falls in place with our Pascal triangle. First and last term are 1, 1. Second and second to the last term are always the value of your power. So we're going to put this now into one expansion. So let's say you have a general expansion like a plus b raised to the power of n. So we're going to impute. Remember I said your binomial theorem helps you to just get your coefficient. Your powers is left to you. So let's first put in powers. You know your power of a will reduce from n to 0, and power of b will increase from 0 to n. So let's put that first. Let's put our a raised power of n, b raised power of 0. Now next term, a will reduce by n minus 1, okay? That's a raised power of n minus 1. Then b will increase from 0 to 1, so it will be b raised to the power of 1 plus so on. You get a raised power of n minus 2, b raised to the power of 2, and so on until you have reduced your a to something like 1. So a is got a raised power of 1. Then b is almost at n. is at increase. Now it's almost at n. Let's say b raised to the power of n minus 1 is almost at n. Then it will also finally change. The last term will now be a raised to the power of 0. That is, a have finally decreased, finished, and b will be raised to the power of n. That is, b has finally increased to the ending. Okay, I left spaces there for we to put our coefficients. Let's put our coefficients. So from binomial theorem, your coefficients, you said the formula is n combination r. So your coefficients for the first term, your first term, the r value is 0, is n combination 0. The second term, the r value is 1, is n combination 1. The third term, r value is 2, n combination 2, and so on and so on. Second to the last term, your r value is n minus 1. So that's n combination n minus 1, like I've explained. And your last term, the r value is n. That's n combination n. So like I've also explained again, for this first term, I have n combination 0. Like I explained, n combination 0 is always 1. So remove the 1 out, it's gone. And the b raised to the power of 0 in that first term, b raised to the power of 0 is 1. So n combination 0 is 1, b raised to the power of 0 is 1. They are out. So what is left there is a raised to the power of n. So that first term is a raised to the power of n. And the second term, you have n combination 1. I just explained also that anytime you see n combination 1, your answer is equal to n. So that's why I'm no more putting combination. So I'm just putting n there. And the b raised to the power of 1, I'm not complicating things, just remove the power of 1 there, because b raised to the power of 1 equal to b. So the second term you have here now is n a raised to the power of n minus 1 b. Then follow it with n combination 2, a raised to the power of n minus 2, b raised to the power of 2, and so on. Then you get to the second to the last term. I also explained, second to the last term, the formula will be that's c combination n minus 1. You get n, so that's n. Then this a raised to the power of 1, if you want to write it as ordinary a, so that's na b raised to the power of minus 1. Then finally the last term, where you have n combination n, a raised to the power of 0, b raised to the power of n. A raised to the power of 0 is 1, so remove it out. N combination n, I also explain it now, n combination n is equal to 1. So that's n combination n is 1, a raised to the power of 0 is 1, they're out. So only b raised to the power of n is there. So in total, your binomial theorem in simple form is a plus b raised to the power of n is equal to a raised to the power of n plus n a raised to the power of n minus 1b plus n combination 2 a raised to the power of n minus 2b raised to the power of 2, and so on. So you get to your second to the last term. That's n a b raised to the power of n minus 1 plus b raised to the power of n. So how do you know when you've gotten to your second to the last term? You'll be counting your terms. Remember, if you're expanding something to the power of 3, after you expand it, you have 4 terms. If you expand something to the power of 6, after you expand it, you have 7 terms. So when you're writing down your expression and you know that you're written up to, let's say I give something with the power of 7, and you're written up to the 8th term. You know that 8, you're written up to the 6th term. That's 6th term is not the last term yet. The 7th term either is the last term. I say raised to the power of 7, so you are expected to have 8th term. The 7th term now will be the second to the last term. So when you got to the second to the last term, so you know that, okay, no more combination, I know the formula already, it's already n that will be there. Before get to the last term, it will just be b raised to the power of n. The second to the last term is n a b raised to the power of n minus 1. No combination in that part, no combination in that part, no n combination. This just know that it's n that will be the coefficient there already. So when you're expanding and you've got to that second to the last term, just put your n, that's your power that you're expanding with. So that's the binomial theorem formula. Now to the question that I should solve, question 1d, right? So that's where you have 2x plus 5y raised to the power of 6. 2x plus 5y raised to the power of 6. Okay, let me rewrite the binomial theorem again so that we'll use it. So binomial theorem, that's a plus b raised to the power of n equal to a raised to the power of n plus n a raised to the power of n minus 1b plus n combination 2a raised to the power of n minus 2 b raised to the power of 2, and so on. So you get to plus n a b raised to the power of n minus 1 plus b raised to the power of n. That's your binomial theorem. So in this case that we have, this expansion example, a is representing 2x, a is not representing only x, a is representing 2x as a whole, and b is representing 5y. Then the power, which is usually n, now is 6. So you have that a is equal to 2x, b is equal to 5y, and n is equal to 6. So we're going to substitute these values inside our binomial theorem. So anywhere we see a, we put 2x. Anywhere we see b, we put 5y. And anywhere we see n, we put 6. So the formula the first part of the formula says a plus b raised to the power of n. So it will now become 2x plus 5y raised to the power of 6, because a is 2x, b is 5y, n is 6. So is equal to the part where you have a raised to the power of n. A is 2x, so that will become 2x raised to the power of 6, because n is 6. So that's the first term. Your second term says n a raised to the power of n minus 1b. Remember, n is 6, so n is 6, a is 2x, put it in a bracket, then n minus 1, n is 6, so 6 minus 1 is 5. So you need to start putting your 6 minus 1, you know 6 minus 1 is 5, just put the power of 5 directly. The power of 5 directly. Then close bracket, 5y. 5y, that's b, because b is 5y. So I just put it then plus, now that's where you have your combination part, that's n combination 2. N, you know that is 6 in this case, so that's 6 combination 2. Then a, you know, is 2x, that's 2x to the power of n minus 2, that's 6 minus 2, which will give you 4. Then b is 5y, b is 5y, so put 5y raised to the power of 2. Then okay, then the next term will be, you keep on going, you keep on increasing your combination from n combination 2, you get to n combination 3, n combination 4, and so on. So this is n combination 3 now are into n combination 3. That will be 6 combination 3, because n is 6. Then your power, remember our powers are increasing, our power of a is increasing, the power of b is reducing. So if you see what we have been doing, the power of a is decreasing from 6 to 5 to 4. Now the power of a will be 3, so that's 2x raised to the power of 3. And our power of b has been increasing. It was first 0, that was invisible there, to 1, to 2, now it's increased to 3, so that's 5y raised to the power of 3. Then we get to the next term. The combination for this term now will be 6 combination 4. 6 combination 4, that's where we are now. That's 2x, then 6 combination 4, then 2x to the power of 2, because remember our power of a is reducing. It was formerly 3, now it's reduced to 2. Then 5y, which is b, is increasing from 3 to 4 now. So that's 5y raised to the power of 4. Then plus, okay, how many terms have we gotten now? We've gotten the first term, that's 2x to the power of 6 in the first term. The next term, we count it. I've gotten 1, 2, 3, 4, 5 terms. Remember, this expansion is to the power of 6. We're expected to have 7 terms. So the next term we're going to get now, which is going to be our 6th term, it's actually going to be the second to the last term. The 6th term will be second to the last term. The 7th term will be the last term. The 6th term will be second to the last term. I remember what I said about second to the last term. For your binomial theorem, second to the last term, you need to put your combination part, just put n there. So you need to put 6 combination n, so just put n, that's 6. According to your binomial theorem that is up above there. So 6 open bracket 2x. Remember from that binomial theorem, second to the last term, the term there is n a b raised to the power of n minus 1. That is n is 6, a is 2x, then b raised to the power of n minus 1. Remember n is 6, so n minus 1 will be 6 minus 1, that's 5. So b, in this case, that we have is 5y. So that second to the last term for what we have is 6 open bracket 2x close bracket open bracket 5y close bracket raised to the power of 5. And finally, your last term, according to the binomial theorem, your last term is b raised to the power of n. And in our case, our b is 5y, n is 6, so that's 5y raised to the power of 6. So you have expanded it, so you just have to simplify it. So we're going to be using calculator to solve the 6 combination, this combination, 6 combination 2, 6 combination 3, 6 combination 4. So for the first term, what we have presently, our first term what we have presently is 2x raised to the power of 6. Now the power of 6 is both for the 2 and both for the x. So when you're getting that power, you get the power of 2 raised to the power of 6, which will give us 64. 2 times 2 times 2 times 2 times 2 times 2. That's 64. Use a calculator or just manually do it. 64. 64x raised to the power of 6. So the x raised to the power of 6, put it. Then plus, so 6 is still outside this bracket. Let's get 2x raised to the power of 5. 2 raised to the power of 5 on its own is 32. That's 2 times 2 times 2 times 2 times 2. That is 32. Then x raised to the power of 5, close bracket. Then 5y is there. Then the next term that has 6 combination 2. If you get 6 combination 2 in your calculator, it's 15. You can manually solve 6 combination 2. You get 15. Now you have 2x raised to the power of 4. 2x raised to the power of 4. 2 raised to the power of 4 is 16. That's 16x raised to the power of 4. Then this side I have 5y raised to the power of 2. 5 raised to the power of 2 itself is 25. So that's 25y squared. So that term that we have there is 15 into bracket 16x raised to the power of 4 into bracket 25y raised to the power of 2. Now let's move on to the next term. Next term has 6 combination 3 as the coefficient. 6 combination 3 in your calculator is 20. So then the 2x raised to the power of 3. 2 raised to the power of 3 itself is 8. So that's 8x raised to the power of 3. Then 5y raised to the power of 3. 5 raised to the power of 3, that is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So that 125y raised to the power of 3. So this term now is 20 into bracket x raised to 8x raised to the power of 3. 125y raised to the power of 3 plus the next term, that's 6 combination 4. 6 combination 4 is actually 15. Okay, then 2x raised to the power of 2. 2 raised to the power of 2 is 4. 5 raised to the power of 4. That is 5 times 5 times 5 times 5. 5 times 5 is 25. 5 times 5 again is 25. 25 times 25 you get 65. So 5y raised to the power of 4 is 625 raised to the power of 4. So that term now is 15 open bracket 4x squared close bracket open bracket 625y raised to the power of 4 close bracket. Then the second to the last term that we have, which will give us 6 open bracket 2x. That is still almost the same. 6 open bracket 2x is consistent. Then the 5y raised to the power of 5. 5 raised to the power of 5 is 3,125. So that's 6 open bracket 2x close bracket open bracket 3,125y raised to the power of 5. Then the last term being 5y raised to the power of 6. 5 raised to the power of 6 is 15,625 y raised to the power of 6. So that's what you have there. Then finally, the last step, just finally expand and make it neat. That's our first term is settled already. It's already okay. That's 64x raised to the power of 6. Then the next term, multiplying out what we have, that's 6 times 32 times 5. You find out that it's giving 960. Right, 960. So put your x is x raised to the power of 5, then put your y, that's just y. So that's 960x raised to the power of 5y. Your next term, multiply the numbers, that's 15 times 16 times 25, which you find out to give you 600. Then put your x and y, x is raised to the power of 4, y is raised to the power of 2. The next term, multiply it up, 20 times 8 times 125, you get 20,000. Then put your x raised to the power of 3, put your y raised to the power of 3, plus the next term, 15 times 4 times 625, you get 37,500. Put your x squared, put your y raised to the power of 4. Then the next term, that's 6 times 2 times 3,125, you get 37,500 again. Then put your x there is just x, no power. The power there is 1 for invisible. Then y raised to the power of 550. Then finally your last term is already settled as 15,625 y raised to the power of 6. So that is your final answer. So your answer is 64x cubed plus 960x to the power of 5, 64x to the power of 6 plus 960x to the power of 5y plus 600x to the power of 4y squared plus 20,000x to the power of 3 y to the power of 3 plus 37,500x squared y to the power of 4 plus 37,500x y to the power of 5 plus 15,625 y to the power of 6. That's the final answer there. Okay, but this values, maybe I made mistake in this multiplying of this term. So if you check it and check it up with calculator, this multiplying, check if there's anyone that's going to be wrong there.